Magnetism, EM scales, and waves. Section 1. Magnetism. A solenoid is a series of coils around a conduct that, when introduced with an electric current, produces a magnetic field. Magnetic domains. They are a region of magnetic materials in which the magnetization is in uniform direction. Magnetic flux. Measurement of the total magnetic field which passes through any given area. Magnetic field lines. Imaginary lines follow between the poles of a magnet. You can see magnetic field lines below. Magnetism is basically when the magnetic domains of a material align and begin going in a uniform direction. The alignment causes the north and south poles to be opposite of each other. Dipoles are microscopic to subatomic dimensions that flow in a loop. Dipoles are electrons that spin on their axis and circulate around a positively charged nucleus. This relation between protons and electrons weakens or strengthens the magnetic fields. You can see the dipoles over. You can see them in the diagram below. Ferromagnetism versus paramagnetism. Paramagnetism refers to materials that become magnetized when introduced to a magnetic field, but lose their magnetism when removed from a field. Please excuse my partner, who is very clearly not a basketball player because he just missed.
Dude, just start. Just restart.
Examples: aluminum.
Dude, there's no point in
I'm going to put this in the project. Ferromagnetism is any material that is magnetized when introduced into a magnetic field, but the material keeps its magnetism after being removed. For example, steel or iron. Magnetic flux. A magnetic flux is a useful way of describing the effects of magnetic fields on something in a given area. The more area in contact with magnetic field, the higher the magnetism/magnetic flux. You can see the Weber below that is used to measure magnetic flux. So I am filming a video over the example of ferromagnets. So as you see here, when I touch this to a paperclip, it's not magnetic at all. But after I introduce it to a magnet and let it stay on there for a second and take it off, it gets magnetic properties. Steel and iron temporarily become a magnet when introduced to another magnet. This is called ferromagnetism.
EM spectrum. The electromagnetic spectrum is a chart that shows the range of frequencies and the wavelengths of electromagnetic radiation. The EM spectrum was created in 1887 by Heinrich Hertz when he performed an experiment where he created a gap between two brass spheres and created a spark between the gap. He was able to see the microscopic spark even though it only appeared for less than a second. He then was able to calculate the speed of radio waves he created and found they were equal to the speed of light. The EM spectrum provides information on different types of waves. This information can be used to help prevent exposure to harmful radiation and also showcase the uses of each type of radiation. Visible light is represented on the spectrum along with radio waves all the way up to gamma rays.
Interesting.
Some higher radiation can cause cancer, and using the EM spectrum can show which forms of radiation must be avoided.
Waves. Waves are a disturbance that travels through matter. There are two types of waves, transverse and electromagnetic, which I'll be talking about later on. The height of the wave is called the amplitude, and the distance from peak to peak, which is the top of the wave, or trough to trough, which is the bottom, is called the wavelength. Electromagnetic waves do not need matter to travel. The EM spectrum measures these waves. Examples of those include radio waves and gamma rays. Transverse waves, or mechanical waves, do need matter to transfer energy. Examples of those are surface ripples on water. Frequency refers to the number of waves produced in a given amount of time. Period refers to the time it takes for one wave cycle to happen. It is represented with a T and is measured in seconds.
This is an example of a wave.